So before we get started, a few questions. How many of you are involved in some form of data crunching, intelligence, something which has anything to do with analytics? How many of you? So the question was, how many of you are involved in any kind of software or otherwise which deals with analytical outcomes? Okay. And how many of you are involved in data creation products, like anything that interacts with the customer, which creates some kind of data or whatever? Okay. Right. So I talk about this under the umbrella of what I call the intelligent enterprise. I think the previous conversation was very valuable in setting the stage for how to do what right? And this is going to talk about how do you think about that how, and what happens in an enterprise which sort of either makes it tick and work or sort of not work because of the way things are thought through and so on. Right? And more specifically, at the end of this, what I want to also leave you with is a new set of tools, hopefully new set of tools, which will give you some flavor of thinking when it comes to solving analytical problems. Right? Let's start with a very simple definition of what is intelligence. I think So I think everyone has a different version of what intelligent means, right? And there probably needs to be some kind of a model where you think about what is intelligence. So if I ask you, what is intelligence to you? I'm sure we'll get many different answers across the room, right? And I don't think there is a fair model of thinking about what is intelligence. It's quite hard because it is ingrained in us. It's inherent to us, right? So what I've tried to do, again, my shabby UX skills, what I've tried to do there is to sort of lay out what could possibly be one of the ways of thinking about intelligence, right? And again, intelligence, I think if you ask a lot of the market, and I think the earlier speaker talked about some of that, like everyone wants to do some kind of AI, ML or whatever, right? So if you ask the market, they'll say anything fancy is intelligence, or some of them also talk about anything that does simple rule-based crunching as also intelligence, right? So when you have this kind of a bizarre spectrum, how do you think about intelligence? So I think this is one of the ways of thinking about intelligence. This is not like the hard and fast rule or whatever. This is just one of the ways of thinking about intelligence. So if you look at IT and software and evolution of software, so we've spent nearly 30 to 40 years building systems that remember stuff, right? Like think of any software that you built, the first software that you built, and it had some notion of a database or a like form which collects some information, etc. You build some notion of what is remembering, right? So you're just remembering stuff in many different ways, right? Now, and that continues to sort of evolve. You have newer ways of remembering stuff. You have graph-based models and sequels and NoSQLs and so on and so forth, right? Is that intelligence? Anyone? Actually, let's go back a bit, right? So let's imagine, let's say Alan Turing trying to solve the Enigma problem, right? From Alan Turing's point of view, if you have a graph database today, and then you store something in the database and query in a very graphish format, it is intelligence. Because intelligence is a ever elusive thing. It's never a point in time, this is intelligence. It's never that, right? So what is intelligent today might be very rudimentary tomorrow, right? So in the 1930s, if you were to imagine or sort of comprehend that you will be able to remember so many things in a tiny chip, it's like impossible. Like, hang on, what are you talking about, right? So the definition of intelligence has evolved over time, right? And very similarly, memory forms the fundamental sort of element or stage of that intelligence. Without memory, you can't have higher order forms of intelligence. So imagine someone who has memory issues, like short-term memory loss and so on and so forth, and their ability is extremely hindered, right? So even from a physical world point of view, intelligence is, I think the memory is the fundamental sort of the beginning of intelligence. Now the next bit that you would have done, let's say from a software point of view, is you would have built business functionality and business rules, and you would have built systems which crunch some of these business rules, workflows, and so on and so forth. I would argue that that was also intelligence. It was just that the intelligence was outside, and then you just translated or transcoded that into some form of a system, right? So the next evolution is, how do you think about rules, and how do you make some kind of a system understand rules, right? So let's take another example. Go to a biophysical sort of an example. So how do you think ants fetch food? Anyone? So you would have seen ants going in line, right? Like, how do you think they go fetch food? Sorry? Yeah, so there is some kind of a serum which is laid by the ants, and they go follow that serum, right? Like, there is a path laid by the serum, whatever. What is that fundamentally, from an intelligence point of view, what is it doing? Right, so I think, so there are many different layers that we'll have to peel. So let's stick to the simplest form of this intelligence, which is, let's not worry about trust and how do you pass on knowledge and so on and so forth. But fundamentally, what is happening is, every ant is designed to sort of scan this serum. It understands serum and that serum alone. Let's say you draw a line, it won't follow your line, right? So it is designed to scan that serum. And what does it do? It says, okay, if this is there, I need to go a step ahead. It's a very simple rule. It's ingrained into the DNA of ants. It's not like that, but I'm just giving you an example, right? So what does that mean? So that is the next rudimentary form of intelligence where you know how to interpret rules, right? Did the ant come up with the rule? Probably not. It was probably a consequence of the evolution, right? So some other form led to this form which created the perhaps, right? Like we have reflexes, like did we come up with the reflex action? Probably not. It's an evolution thing, right? So which means after memory, the next order of intelligence could be probably rules, right? So if you could imagine, let's say, a rule processor like an Excel in the 1950s, it would have been probably quite bizarre. Like, hang on, it's impossible to process these many cells in this much amount of time for these kinds of, filters, pivots, whatever, right? So for the 1950s, AI, the state of AI, was rule processing. Right? Again, all of these numbers are quite arbitrary. I'm just trying to make a point of how is it evolutionary, right? It's not a point in time thing. Today, however, if you read any of the technology savvy, let's say journals or marketing websites or whatever, one of the things that you'll hear is deep learning and machine learning and AI and so on and so forth. So what is intelligence today will not be the same tomorrow. Right? So we have established that fact. Let's move on. Now, why does this become interesting? Like, if we have had this normal evolution, why is this interesting now? It was interesting then, it is interesting now. What is different? Right? So I think one thing changes, and that's sort of the flip of the dial, if I were to call it so. That is, a lot of the previous set of stuff that we talked about, memory and rule, is humans translating their notion of what is intelligence onto some kind of a system, right? So you encoded intelligence into some kind of a systemic thing, right? Whereas what is changing, or for the past 20 years, what has been changing, at least academically, is that you no more have to encode that intelligence. You can elicit that if you have enough data, right? So why didn't this start 20 years ago? Why is it a thing now? So it is a thing now because we have more data creation systems, and there is more data, and hence you can explore some of these methodologies, etc. Right? So that's sort of the rationale of what is happening and why it is happening. Right? Now there are again different forms of what are the granularities of these inference-based solutions, and often inference is laid from some data. Like there's a lot of technical jargons. Let's not worry about that. So this is just to give you a flavor of when we say intelligence, what does that mean? It's not just the AI and the MLs of the world. It's also some of the stuff that were quite old. However, you can't define it as a point thing, right? So that's the point. Now, is that enough? Let's say you have that understanding. Can you go run an enterprise and make it intelligent? Is that possible? Well, probably not, right? So there is another dimension to this which is fundamental in making it useful and successful, right? So what is this dimension? So let's say you are and this is nothing against any religion, this is just a simple intelligence example, right? So let's say you are a yogi, right? And you've read all the Vedas. Let's say Veda was the state of the art at that time. And then you're sitting in Himalayas, you have all that knowledge. Are you intelligent? Would you consider that person intelligent? There is some semblance of intelligence because you're able to remember everything. Probably you're able to comprehend some of the rules and elicit some of those rules, preach the rules, etc. But if you're sitting in a corner and doing nothing with it, it stops there. The intelligence level stops there. The higher order point is adoption of that knowledge into useful bits is another dimension to look at, right? So often what happens is a lot of the people want to build models, right? But they just don't know how to use it and how does it make business sense, right? Like all of them will bring in a deep learning model or a TensorFlow or whatever and say, hey, this is the thing to do. Let's go do that. Okay, so what, right? So what this sort of suggests is some kind of a breakdown of how you can look at some of these situations in an enterprise or otherwise, and then sort of rationalize why things are happening the way they're happening. So for example, let's take Uber, previous example, right? So Uber could have said, you know what, we will publish a price list to you. Every day, morning, you'll get a price list in the email. Like it's a very technology-driven solution, is it not? Right? So now, why haven't they done that? Why don't you get a price list in the morning? Sorry? Right, so I think there are two things happening there. So one is, how do you so price list is again another form of intelligence, right? Some memory, whatever. Someone compiled that outside, and then now they're telling you this is the price for your journey, right? So the trouble with this is, you are not giving that decisioning or decision support thing at the right point in time. You're just doing it every now and then, and sometimes it becomes irrelevant. It's just a human thing, right? So how did they get that sweet spot? The sweet spot is before you book, before you get a cab, depending on all the conditions around, like traffic zyada hai, like some more pricing, whatever, and that's when you get the price, right? And then people are okay paying that because that's the need of the hour. Like it's either they do it or they don't have it, right? So, which essentially means adoption of that technology has a full cycle, and we'll talk about what that cycle is, why is that cycle, so and so on, right? So, point there is, that is the epitome of adoption. That is, at the right point in time, at the right instance, you have that intelligence available. And it can be as simple as compile that price list into, yahan se yahan hai, okay, this fellow gets this price. It could be that. It doesn't have to be very sophisticated. Oh, there is traffic there. There is, it's raining outside and it's Bangalore, Kormangala, whatever, right? So it doesn't have to be any of that. It could be as simple as from this place to that place, this is a price. Okay, at the point of delivery, here is a price, right? So that's the epitome of adoption. And you will see this over and over again in many of the successfully adopted AI companies, right? So if you look at Amazon, they could also do this price. Can I give you the sort of the catalog? And then you look at the catalog offline. They could do that, right? So the reason why it is involved, in addition to many of the design reasons and some of the psychology reasons, etc., one of the reasons why they're able to sort of adopt this well is because of that right time. How do I get that thing at the right time? It doesn't have to be real time. It just has to be at the right time, right? Now, there will be certain other firms, and then again, this also makes them interesting because you are now fundamentally basing business decisions, which is something like a pricing, purely based on some data that you've seen in the past. And you could do that. You have the opportunity to do that. Whether they do that depend and makes them plot into different segments. But if you look at the examples that I talked about, they do that to an extent, right? To a large extent, they do that, and hence they're in that sort of the leader position when it comes to adoption, right? And they're in the leader also because they have that sophistication thing going well, right? So they're able to apply some of the emerging technologies at the right instance and time, and then they're able to make business decision at the right instance and time, and then it's like a sweet spot, right? Now there are certain other categories, and this is a very small example from one of the conversations that I had a few years ago with someone where they were saying their previous company in the UK, someone said, hey, this Netflix thing the internet is a fad, this Netflix thing is going away, I want to keep making DVDs. And this was a comment from the CEO or whatever. right? And it could be twofold reason, right? So one is you're not aware of the market, you're not able to perceive what is the impact of the new technology, blah, blah, blah. But in addition to that, you're not able to sense signals which you can use to make some kind of a decision. You're fundamentally averse to sensing signals, right? It's like, I don't want to look at this data, I want to do what I have as my opinion. I think it's okay to some extent. It's just that often opinions are proven to be wrong, right? Again, I don't mean, I don't want to generalize this. This often happens, right? So you can look at that in many of the decisions that we take in our life, right? Like none of us are data-driven. Like very rarely are we data-driven, right? But often when it is at a scale of an enterprise, doing that aversion sort of hurts you, and then that's why you would put them in a ripe for disruption sort of a bucket, right? So where your ability to adopt the sophistication of intelligence is fairly low, and then your ability to adopt intelligence itself into your business is fairly low, right? So, and that's the potential, like the point of disruption, whatever. And I think the interesting bit for all of this, we can talk about all the four quadrants perhaps, but the more interesting bit is there are two fundamental chasms that are visible and evident, right? So that is from human intelligence to crossing over to machine intelligence, which is not the intelligence not being encoded by a human being, but elicited from the data, and from being aware to actually using stuff in your business when it comes to insights and intelligence, etc. Right? So those are the two chasms that you'll have to recognize and cross them appropriately. And it's not an easy chasm to sort of cross. So if you have to go up this ladder, then you need the new capability, and more importantly, you need the data, right? So without data, that crossing this chasm is, like, forget it, right? And the horizontal is, you need the capability, but you also need the culture of adopting that. So you can't have a Uber with a very waterfallish culture. It's very hard to do it. It's not that it's impossible, but it's very hard to do it, right? Let's talk about one more example, perhaps. So there was this company called Get Prismatic. Anyone remembers Get Prismatic? This was a very successful, well, I say successful. So it was a company which sort of moved a lot of needles when it came to the state of the art of machine learning in the business of news curation and content aggregation, right? So Get Prismatic was a news curation sort of a company. And they had a very interesting philosophy. The founder was brilliant, like the right set of people going, like everything was going well for them. Just that they had not figured out how to adopt this to make money, right? So from an adoption point of view, they were aware, and they were probably using, but their sophistication was extremely high. Like I think they built some really interesting stuff in Clojure, which was never built before, and so on and so forth. So what I would place them in the first quadrant from the left, if I were to call it so. And they were very intelligent focused, but they didn't figure out how to make it business relevant, right? So that's another thing to sort of avoid. So often the question that I get asked in a lot of the companies is, okay, how do we become leader? Like, give me the recipe. Right? There isn't typically a recipe. So the idea should be to not embrace either. The idea should be to embrace both, right? So you can't just change your culture and then get there. Not possible. You can't just adopt technology and get there. Right? So it's a combination of both of them going well for you. So just to put color to that, I think this are done for an internal portfolio or whatever, but these are some of the more generic outside examples. And if you see, let's say on the bottom left, Sears, Kodak, and so on, at least Kodak's example, I think, is fundamentally averse, where they avoided everything to do with digital evolution, right? Like I think now they're catching up, etc. Very similar story with Sears. I think Yahoo had a very similar or an interesting journey where they were probably one of the first set of people to adopt technology to an extent which is unimaginable at the point in time. However, business relevance of that was a challenge for like Yahoo, right? Also, whenever it was business relevant, it was not sophisticated enough. Like the not right time thing was sort of going for Yahoo. I think the other company that's there is, I think I've put MCK McKinsey, but it could be any of the big four. And the point there is strategy consulting or strategy as a thing often is at least using some data, right? So how good the data is, or how rich the data is a different sort of conversation. However, any decision that a strategy firm sort of, yeah, so any decision that a strategy firm sort of gives you often is backed with an Excel sheet. Like, here is an Excel sheet. This is why you should do this, right? So which essentially means they are using data all the time, right? Sometimes the sophistication is like, it's an Excel sheet, right? So you can do very interesting stuff with Excel sheet, but it's not the state-of-the-art, cutting edge, what can push the boundary sort of a thing. So does that, so what does that mean? Should you not do strategy? Absolutely, you should do strategy, maybe, right? But that's not enough. You can't just stop there, right? So if you stop there, you're on that sort of the side of the quadrant. Now, why are we talking about all this? So this is to give you context of what is required to sort of survive in, or more than survive, thrive in this sort of a world where there is more than one parameter involved, which will influence your success, failure, etc. Right? Now, I think in the second half we'll talk about what are the cycles involved. But I think, given this is a forum of business people and people who are close to business, what I want to talk about is a different framework or way of thinking as to how you make a process that is nonlinear. We'll talk about what is nonlinear into pseudo-linear, if I were to call it so, right? Often, so if some of you who are part of some of these analytical products, what are different sort of personas that are involved? Can you name a certain personas who come into play when you're building such products? Anyone? Sure. So I think the question was more who builds these products, not just the target, but who actually is involved in building the product. So often it's some kind of a engineer who will put things together. It'll be some kind of a analyst or a scientist who will do some exploration. There'll be some form of a product management involved. There are like a bunch of these familiar roles involved, right? So one of the things that happens is the typical sort of analytical project would look something like this, right? So where you have three fundamental aspects of the project, right? So you'll have product research. I've combined UX and product thinking, etc., into product research, forgive me. And then you'll have technology, which you'll have to build to get some higher order value, whatever. And then you'll have data and experimentation, right? And this data and experimentation, some of us don't like it. Like, ये बहुत math है भाई, like इसको नहीं करना है. We don't want to do this, right? Or we will offload it to like another set of people and say, hey, this is you. You have a PhD in something, you have that in something, and you guys do it. And often this precedes everything else. Like there's a lot of research that happens before that going into any kind of a product, right? And often this research is very, shall we say, data-centric, which is good, but it's also very mathematical, right? And mathematics is not bad. It's just that mathematics in isolation is probably not useful, right? So let's say at the end of this research phase, someone comes up with let's say I'm the data scientist, whatever, I come and tell you, hey, I have a really good deep learning model which gives you like 90% accuracy. Okay, so what? Right, so then there starts a process of, okay, this is 90% accuracy, okay, it requires these things, okay, how can you use this? And then there's a process that is kick-started, which will sort of translate that to some kind of a product lifecycle, right? Is there anything wrong with this? Probably not. But, however, I think there's a better way of doing this. And then we'll talk about what are the challenges in some of this, right? So if you go to the previous one, I think one of the interesting things that happens is constantly we argue about why the user should be part of the technology journey, right? And that's a good thing, right? So you're building it for a consumer, and the consumer must be part of the technology journey. You can't just build technology in isolation, right? And that product track ensures in some fashion that you're building the right thing and you're building it the right way, right? But what is missing in all this is this experimentation thing doesn't care about user. Like, what? User? No, data is there, that's enough. Like math, it's the purest thing or whatever, right? So it might be. However, I think there is another rationalization for this, right? So if you look at the cadences across these three different streams, the product stream will come to. So let's say technology stream, right? So we've been doing technology for what? Nearly 30, in a commodity fashion, we've been doing it for 25, 30 years, right? And over the course of this, we've figured out the waterfalls of the world, we've figured out the agiles of the world, the leans of the world, and like we've a bunch of models. What do these models help with? They help you linearize what is a non-linear knowledge process, right? So building software, you can always sit in a corner, accumulate everything, and then build software, right? It's quite possible. And then that is like a bell curve sort of a process. Your creation of value is centered somewhere, and then that's a problem. Because it's not like linearized, and it's not spread out, and you can't see immediate value, blah, 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 right? So some of these agile and lean and like a bunch of these methodologies sort of bring some linearity into value creation, right? So it doesn't make the knowledge process linear, it just makes the process of value creation slightly linear, right? So every iteration or every release, you will get some bit of functionality which is business relevant, you know the story, right? So that's technology. I think we've figured out some of this over the course of 30 years, etc. With product research, I think it's much harder there. So software can be added, whereas product research and user, it's quite hard to add user thing into a linear thing, right? So, but however, over the course of these years, we built so many consumer products that we figured out a way to make it slightly linear, right? So even though the process is non-linear, we figured out a way to join a bunch of these processes and say, okay, user said this here, that there, okay, this is how it should evolve, right? So there is some method to madness. I think there are many handguides of how product should be run, and there are many people here who can talk more and better than me about how to run product teams, etc. Right? So there is some method to madness there. And then comes the data experimentation thing. This thing is weird. It's like a bunch of introvert scientists sitting in a corner, almost always in a basement. And this is a true story. Like I've been in many basements, and not in a weird way, right? So and a lot of these people come with really strong academic skills, but not necessarily engineering skills always. Some of them do have engineering skills, but not focusing on linearization as a skill, right? So often data experimentation, like the name suggests, experimentation involves failure, and failures are very hard to make business move, right? If business doesn't like failure, no, always show a straight line, right? So how do you make something that fails predictable, right? It's quite hard, right? So there is a trough of some sort when you hit, like, let's say you're trying to model something, and then you don't get the results. Let's say you got 50% accuracy, whatever the accuracy. Forget accuracy, whatever the metric, right? And at some point in time, it'll be like a dip, and the business is making noise. Oh, I don't trust this data science team, or like some such thing, right? Now the trouble is, it's not that the data science is wrong, or it's not that the science is wrong. It's just that the process of science allows for troughs and like the ups and downs, right? And what we are trying to do is engineering. We're building stuff, but science is a journey of discovery, right? Like almost always, you're trying to figure out what is the best thing to sort of model this behavior, etc. And that becomes the challenge for merging all the three together. Like, how do you make them work together so that you create a higher order, more valuable product? Is the sort of the cracking the nut? Like, how do you make that happen is a challenge, right? So I think the solution that we often talk about is what is called as Tripledrag. I mean, I don't want to talk about Tripledrag, but the fundamental principle there is when you're doing analysis, can you link your analysis to the user? Like, how do you go and say, hey, user, I found this in the data. Do you agree? And that's a fair question to ask. Like, why don't we do that? Right? And it's not like bizarrely different. I'm not preaching like a new novel idea. I mean, this is fundamentals, right? So how do we make that happen? I think that is where some of the nonlinearity can be reduced. Right? For example, instead of modeling 20 different variables that influence the thing, if you speak to the user and then they care about only, let's say, 5 of them, then you don't need the 20 different thing, which creates a lot of problems with the model, right? So, and there is some cadence that is required across the data experimentation to the product sort of world. And I think currently there is like a fundamental barrier of, hey, the product people saying, hey, I don't understand this data thing, like, nahi karna mujhe, right? And very similarly, the data people saying, hey, this product thing is too slow, man. Like, I just want to get this done, right? So I think there needs to be some kind of a cadence. Do I have an answer to that? I don't think so, right? And I think you guys are in a better position to sort of think about some of these problems. I'm just trying to surface what problem exists and how you can think about solving some of these, right? Now, let's say there is Tripledrag, and we can talk about this for a few hours, right? Let's not do that. However, one of the fundamental things that is missing is the cause for linearity. I think the cause for linearity was our ability to break down work, division of labor, whatever, right, into some small segments which are additive, right? Like a story, iteration, blah, blah, blah. These are smaller pieces of a massive thing which can be added to create the massive thing, right? And that existed in, I think it existed in all of the methodologies that we have followed. Like some notion of that existed in all of the methodologies that we have followed, right? And that gives you that flavor of linearity, right? Now, what is the equivalent of that in experimentation? Like, can you say as a user, blah, blah, blah? It's quite hard, right? Because if you say one of the as a user story, it might translate into like 50 hypotheses and 20 experiments, right? And it's quite hard to say, okay, this one will lead to this and this alone, right? And this is it's not really a joke. It's like a genuine problem, right? So how do you think about modeling that? Like, what is the story equivalent of experimentation? Like, what is that? And this could be one of such ways of thinking, right? So the inspiration for this is Robert Fisher. He's a British scientist in the early 1900s. And he was a chemist, right? So his problem was he was doing a lot of these experiments. And then he had a very hard time figuring out, how do I make sense of all of these experiments? How do I try this solution, concentrate, and then try something else? Right? So that was his problem. Like, he was a chemist trying to solve this problem. And then he wrote a book in 1930, I think, called The Design of Experiments. And it's one of the only good books around design of experiments. And I think there have been plenty after. And that lays out the fundamental principle of how do you perform experiments which are statistically relevant. And there's some mathematics behind that, right? So what this model sort of lays out, again, this looks complex, but it's not. What it lays out is outcome depends in a data-centric world. Outcome depends on many different things. I think, but we tend to talk about models, right? So the bottom bit is what we talk about, right? So, however, what we don't consider is what is driving the model. And this is never a conversation I've heard, at least from what I've seen, between a data scientist and, let's say, a BA or a product person, saying, okay, what is your mathematical hypothesis? Never happens, right? So, and probably that should happen. Like, it can be made more accessible, and then there are ways of having that conversation. I think that is useful. Like, how does outcome depend on the hypothesis? For example, often people say, you should do linear regression. Most of you would have heard of linear regression somewhere, right? Like, okay, why should you do linear regression? Why do you think it'll work? Right? And that why is typically answered by a mathematical hypothesis. Or because these variables are linearly correlated, and hence they tend to work together linearly, and hence you should have a linear, something like that, right? And that's a conversation with the data sort of a person. And more importantly, a lot of the times the conversation revolves around data chahiye, data chahiye, data chahiye, data chahiye. Like, but okay, why? Like, what's the point of data chahiye? Like, why do you need data, right? And the reason why that happens is because your mathematical hypothesis depends on that data, right? If you have different kinds of behavior captured in data, the mathematical hypothesis can be different, and hence the outcome is different, and the behavior is different, and so on and so forth. And then there are control parameters where someone will, I don't know if you've been in some of these teams where you'll hear people saying, oh, I moved it from 60% accuracy to 90% accuracy. How do you do that? Like, magic thodi kya, nahi? So one of the ways of influencing that is using some of these tuning control parameters, whatever. So now, why is this useful? Like, you might say, hang on, this is still academic. This still sounds like basement stuff, right? Like, why is this useful? So the reason why this is useful is because you could now formulate a business hypothesis in a mathematical sense, keeping some of these constant, right? So you could say, given this data, given this business hypothesis, I want to try and see if this mathematical thing makes sense, right? And then you can try that in a very systematic sort of fashion, right? So you don't have to do like really random stuff. Like someone said linear regression, someone else said like I want to try some Newton-Raphson's method. Like what? They're not related. Like what? Right? So this gives you that framework of how to control that evolution and how to sort of think about laying these problems down. I do admit that in order to do this, you've got to have some skills on how do you think about analytical things. But that's not. I don't think it's a it's a massive leap to go get that skill, right? So it'll come over time. It'll come with certain courses and certain focus, etc. That's not enough. Like you can't just have that. So in the software world, like every other, like often two kinds of stories are almost similar. When I say similar, it's similar in its additive sense. Like if you play one story and then you play another story, it's very unlikely that you are having a detrimental effect on the system. Well, most of the devs here are not there, so I think I can say that, right? So, but it's going towards some kind of a solution of some sort, right? And what this sort of lays out is you can't do that, one story model and then repeat that across like all of the stories, whatever. I think experiments are fundamentally different. Experiments will have 4 primary stages, I think, right? And often, a lot of time we talk about those stages. How do you get the model? How do you increase the accuracy? How do you get the model? How do you increase the accuracy? Right? But what we discount is how did you actually get to the model? And what influences a lot of the outcomes and why things are the way they are is because how you got to the model, right? And the previous model that you saw of how to structure like a linear thinking process, etc., is often useful here, right? Where as a business person, as a product person, you could say, hey, you know what, I think I have a hunch. I want to verify that with the data. What is my hunch? Let's say you're from Uber. Your hunch is, I think if I price things differently, when there is peak hours, I might make more money, right? So you'll now run an experiment which is very physical to say, okay, let's just change, 6 to 9, let's just change the price. And then you'll go run a verification experiment to say, oh, okay, I know I changed the price. Can you tell me if my revenue went up or down, right? So this is not rocket science. Like this is very simple, like can I do a select star from count or something like that, right? So the point is, you're trying to make a process that was somewhat a black box and disconnected from business more relevant to business, right? And it could also act like a way of creating that backlog and so on and so forth. And if you do enough of these, you can then say, oh, I know these are the 3 variables that influence my revenue, like raining or not, how many people are asking this or not, what is the time of the day, blah, blah, blah. Then you can stick in a model and say, okay, all of these variables influence, let's figure out a mathematical hypothesis, let's create a model, then let's stick it in the product, right? And then you don't have to do a lot of these over and over again like you did the previous time, like figuring out how much to raise, how much to sort of dip and so on and so forth. And then there is another cycle of once you put the model, you will then optimize that, you will change that, you will evolve that. And then you will reach a state where, okay, I think this is good enough. Now let's go somewhere else, right? And then you will again come back to this, discover, verify. After you verified, okay, model, optimize. This cycle sort of continues, right? So what this essentially lays out is like a method of thinking of how do you break the problem down, right? And how do you break the problem down, which translates to some kind of a technology roadmap or a product roadmap or the Tripledrag thing that we talked about earlier. While you're building technology, which is creating data for you, how do you use that and make more from that piece of data, right? And if you do that in a Tripledrag-ish sort of fashion, you'll be able to ask these questions. If I change this variable, what happens? How did the user behave? How did it come back to data, like back and forth, right? So in fact, the epitome of this is if your data, like the product backlog, is purely based on the experiments. That's like the ultimate state where you don't have a product backlog if you're not running experiments. And it might sound like a cult, like, kya bol rahe ho? Like, what the hell? I need to have a product backlog, like, mujhe estimate karna. Sure, but the point here is, one of the ways of doing the building right and staying close to the demand and staying close to the market is by constantly measuring the market. And this sort of frameworks might help ease that gap. I'm going to skip the previous one. So I think I have 5 minutes. What I want to quickly walk you through is what happens in the current journey. I think it'll be easier for you to relate back and then think, okay, why is some of this necessary, right? So think of a classic digital organization. What would happen? There'll be a bunch of people who will make a bunch of decisions, and then there'll be technology people who will make it happen. And then often the product, the business analysis sort of function sits there, right, in that boundary. And someone would say, I want to build an app, blah, blah, blah. Okay, how do you do it? How do you make it user relevant, business relevant, blah, blah, blah. And then like the sort of the process kicks in. Then comes the agile, the continuous delivery, all the shebang, right? And then there is this weird basement gang, which is like, हाँ ये लोग data create कर रहे हैं, हम लोग क्या करें, right? And then there were warehouse people who will do like a lot of data warehousing, and then there are some analyst people who will say, oh, I'll create reports for you, blah, 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 right? Fundamentally, if you look at the history and then if you analyze the history, they're disconnected. They don't speak to each other, right? And I'd be happy to be proven wrong. Often that is the case, at least from the clients that I speak to. But what I'm missing is the big picture. Like, why should you do that cycle, like the top cycle and the bottom cycle? Shouldn't we be doing the full cycle? Like when you create the data, you model the data, you analyze the data, you create a report, you get the insight, you take the decision, you put the action in play, and then say what happens. Because the whole point of doing this is to get that full cycle, isn't it? It doesn't matter if you have the report. Like, what's the point of the report if you're not able to use the report? If you're not able to take a decision on the back of the report, if you're not able to action the report, right? So sometimes maybe report as an artifact is probably wrong. You don't have to have that. Like, think about Uber's example, right? Like that price list as an artifact, irrelevant. Like, what's the point of the price list? Right? It is required for someone who's making the decision, maybe in the old system, this is theory of constraints, right? Whereas in the new system, it's probably not relevant, right? Now, how do you get there? So often you will have these, I think we talked about some of these processes, right? It's always a toss over the wall. Okay, your deliverable is get me the report, and then baad mein sab ho jayega, right? No, there is no complete cycle, whatever. And someone will, the newer, like the 5-6-year-old old technology journey looks like, oh, we need to get rid of the warehouse. Like, bahut slow hai. Like, you have to maintain, like, you have to pay a lot of money, blah, 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 right? And then what do we stick in? We stick in a Hadoop or a system that is massive and it scales well and blah, blah, blah. But what have we solved? We've just solved that bit of the problem. To begin with, that probably was not the problem. Maybe it was, but maybe it was not, right? So you're still missing the rest of the picture. Now, what is a potential solution, right? So now think product, like everyone should clap. So thinking product essentially means multiple things, right? So one is the previous stuff that we talked about. How do you bring that into play, right? How do you bring that, which is very analytical, right? And then how do you keep analysts, scientists, decision makers, decision owners as part of the product, right? Like the person making the decision, if they're disconnected from the creation of the insight, then what's the point of the insight, right? And then this is something that, at least in ThoughtWorks, we take it to heart, perhaps. So Sapto is one of our CEO, is constantly involved in a lot of these insight products. Like, if you're doing something else, I don't want to know. You should be doing what I want to actually make decisions on, or whatever, right? So I think that helps. Now, is that enough? It's not. So if it is just the decision owners, and if it's just a bunch of people creating the decision, I think it's still activity, right? Like, I think it's a useful activity. It's a first step in the right direction, but it's not enough, right? So what do you do then? So then the eventual goal is to get to an action. Like, on the basis of the decision, you want to get to some kind of an action. Now you get to the action. Let's say you're able to expand the remit of the product and get to an action. Is that enough? That's also not enough. So then what do you do? So look at the Ubers of the world. They don't say, I have a pricing engine somewhere in the back end. Like app se uska kuch lena dena nahi hai. They don't say that, right? So pricing is fundamentally integrated in the app. Like it is there when it is required, right? So which means it's no more an analytical insight thing, right? So it's actually my operational technology, right? So that product is not a out there like wahan pe hai basement mein thing. It's a actually 7th floor thing, right? So, and when you get to that state, what happens is a lot of these boundaries, culturally, they need to be removed, firstly. Secondly, what happens is you move from a decision-making system to a decision-tuning system. Now you'll start playing around with it. Like a product owner or an analyst in Uber, again, this is a hypothesis, I've never met any one of them, right? So might be thinking, hang on, like Pune mein aaj barish hoga, like it's going to rain in Pune, and it looks like there's going to be some construction happening on the road. I'm going to surge it. Like, let's go crazy, right? And then they'll be able to verify that. That's because they're tuning what they're thinking, right? And it is possible for a lot of the businesses to get there. Again, it's a journey that I just talked about. Like, it's not a one-step thing. It's a many steps thing, right? And it is never okay, this is the golden solution, whatever. Again, it has many different dimensions to that solution. Earlier, we talked about how do you adopt, how do you do sophistication, blah, blah, blah. How do you do experimentation? How do you do stories and break them into experiments? How do you do like the evolution of the experiment? All of that needs to be in place for someone to be at that state, right? And this is what I typically describe as an intelligent enterprise, right? And it's quite hard to find a lot of examples of these, right? But there are some, and then all of them are retrospectively sort of thought of. It was never designed, and this is a retrospective analysis of some of that, right? So I think there's a lot more. I'm told there's no time. So, questions?
All right, then we'll just let this sink in, and then your questions can come during the break. Thanks a lot, Pramod. That was really insightful. And if I can, just one second, request Doobie to please give a token of appreciation to Pramod. Thank you. And we'll break for 10 minutes now. So you have tea and snacks will be served, and then we'll be back for the next talk. Cool.